can get. Right, let's see if this battery is better. Is there anyone who's out there who can verify that the battery or the sound is better? All right, great, thank you. Right, so today's topic should be the query language and a few other things here as well. Let's just get started. You already know by now that the relational model has been here for a few years, and it was that Dr. Codd, I think, who came up with these things, and he made a contribution to the excellent magazine Communications of the ACM back in the 1970s. And it is from that model that we are able to create those databases that we know as for today. And this is a typical table or a relation, and I think that we're mostly going to talk about tables today, actual tables more than relations, because the queries works on tables, even though we are or has been talking about those projections and selections from the last lecture where I did talk about schemas and relations. So I think perhaps most of you have heard of the concept of a table. So we have this table named ages, where there are two attributes or two columns named person and age, and they also have values which were the tuples or the rows. So the columns are the vertical ones and the rows are the horizontal ones. So for instance, the person Alice has an age of 25. You should also note that sometimes the SQL server has some reserved keywords, and as it said here, person is sometimes a keyword which will make that creation of that table being erroneous, and you will get an error message back telling them that that's not possible. So just keep that in mind. So if, for instance, if you name an attribute like integer or something, it will sort of strike back at it. And we had a bit of a discussion about those relational algebras, those operators, the projections, and the selections. And we had a discussion about what happens if you want to get those persons who have an age below 20. And the only thing we're interested is the person himself. So just show me all the persons who are younger than 20 years. That's what that middle line says. And we also had the possibility to add more to it. We could use those joins. We talked about natural joins that were joining attributes of the same name and try to figure out whether they were matching or not. And we had a few different types of joins, theta joins, equi joins, and anti-joins, and all that stuff. So the lower road is a natural join, joining together those two relations, or those two tables, ages and addresses. And if they are matching and also have the city of Kalmar in common, then they are projected, or sorry, selected, and then we are just projecting or retrieving the age column. And those are projections, selections, and joins are also a part of the query languages these days. You can get hold of them just by asking them. There are intersections and unions and joins at your hand if you want to use them. So without those queries, we would be in serious trouble, because we would be able to add things to those tables but not ask for retrieval of their data. So they came up with that structured query language, SQL, or sometimes just SQL. I think that most people say SQL. Perhaps if you meet with some old-timers, they would probably say SQL too. But that's what I mean, the SQL. And it's a sort of a programming language that you can use. It's mostly declarative, but there are some, as they say here, procedural elements. So you can actually create a shorter or a smaller program if you want to. It is not as good as, let's say, C# or Java. It's not even near it, but it sort of helps it out here. In combination with stored procedures and the concept of stored procedures and triggers and some other constructs of the SQL Server, you can get by quite long. So that SQL, or that SQL language, is divided into two parts: the data definition language and the data manipulation language. So when you're creating stuff, you're using the DDL, and when you try to manipulate it, you are using the DML. And there's also a third one, the DCL, that's the data control language. And then just a note on those standards again. Standards are very good. The problem is that there are so many of them. What you see here is the SQL 92 standard. There are some later ones, but this one will hold for us and will do us quite good. And we also have a few language elements. We have those clauses, which are the parts of things. We can use clauses to create selections if we want to, for instance. and we use expressions to produce values. Expressions returns things, whereas statements don't. They don't return anything, they just do something. And we also have that predicates, which returns something that is either true or false. And also those queries, which we use to get the data from the tables. And those expressions there, if you have a look at that section there, it says that you can either use them for scalar values or tables or a few rows. So you can actually create, from a query, you can actually create another table if you want to. You can use temporary tables, and some people do. But that's not part of this course. We wouldn't be able to practice it anyway. So if we have this this update query, where we are supposed to update a table named country and set the population attribute, or at least we are going to increment that population attribute by 1, where the name is USA. So an expression, that's the population plus 1. It's also we also have a predicate here, which is the test for equality between whatever is in the name and the United States of America, USA. We also have those clauses to the left, and some of them can be omitted. They are optional. Which one? Well, you have to have a look in the manual for that. And some of these clauses and some of these query types are quite intricate when it comes to what you can do and what you cannot do. I think that most of the queries we're going to use today are fairly simple. They can be tremendously more complex if you want to. So that data definition is there for you if you want to, for instance, create a new database, or if you want to create a new table, or if you want to create a new view or a store procedure. And when you are using create, you are not adding data, you're just creating the schema, this table itself. So if you have created a table and then you want to remove it entirely from the database, then you use the drop keyword. That's the drop clause. That will erase that table from the database. And just a bit of a warning here. If the DBA hasn't set the authorization correctly, you might by accident actually drop a table. And the same goes with deleting its content. It's quite easy to delete the content and then drop the table. And if that DBA hasn't set up the backup mechanism correctly or switched on the logging correctly, you will not be able to get it back. So in a matter of few seconds, you can wreak havoc in a database. And I'm telling you that because I have done it. I have also managed to switch off the SQL server by mistake. I have made all possible. I think I've done, if there are 100 types of mistakes you can make, I think I've done them all. But that's more due to me want to figure out how things work, and sometimes that strategy sort of strikes back. So that's why I know that dropping a table is not that complicated. So, but if you want to alter the table, I mean its configuration, its setup, its schema, then you use the alter the alter construct. So for instance, if you want to add a new column or a new attribute, then you go for the alter construct. Or if you want to add, let's say, a type of an attribute. It's not that easy. Sometimes it's not that easy to alter a table when it's live. Let's just assume that you want to change something from an integer into a string. Well, the problem is that it might work, but your users of that table, which usually are the programmers, they are going for the integer, and you have just turned it into a string. And that's not very nice. And that's the syntax for creating a table. You just have to read it right. Just follow the arrows, the paths. So let's assume that we start with a create. Then you can create a table, and if it doesn't exist, you will go back to the name of the table, the schema name, which is the database, its domain, and then you have dot and its table name, and then you move on. So sometimes when you can just pass by some of these constructs, that means that you have an option. So let's start from table once more. That table oval. So you can either go down to check if it exists or not, or you can just omit that checking and just pass it by. So that's the way to read it. And if you go to the column def rectangle, you see that it's a sort of a loop. So you just loop, means that you're sort of adding columns as long as you feel like it. Some of the vendors use other means for describing the syntax for a certain clause or a manipulation language construct. Does it feel? Is it uncomfortable having a look at that schema? No? It's all right? I mean, most of us just go for Google. If you're going to create a table, let's go for Google and have a look at it. And when you figure that one out, well, sometimes you go back to that one. So, aha, okay, that's what they were meaning. So if we're talking about tables now, we also need some types. And there are quite a lot of different types. These are some of the more common ones. The integers, the reals, the characters, and the variable characters. The difference between char and varchar is that if you are using character and you tell it to use a maximum of 10 characters, well, then there's a rule here. If you tell it to store 10 characters, it will always store 10 characters. So even if you are using 4 of them, then it will append 6 spaces, I think. So it always adds up to 10 characters. If you go with the varchar, it uses the exact amount that you actually need. So if you're adding a row where you are using a name, let's say Anna, well, then that's 4 characters, and that's what it needs, just 4. So try to remember that. I think most of you will go with the varchar type and tell them that we need a maximum of, let's say, 255. So that whatever attribute you have there cannot be any longer than 255 characters. So just have a look in that manual. It depends on whether you are using MySQL or MariaDB or any of the other types that are out there. I don't think this is a problem because you're already used to it if you're sort of using Java or C# or any of those languages. And that's the server we have been using for these examples that you will be seeing in a few minutes. That's a SQLite. It's quite brutal. It's there is no graphical user interface here. You have the command interpreter. So you are actually writing down the commands. But it's open source. So these are some of the types that exist in SQLite 3, and just have a look at one thing here. If you are running out of memory, or you know that you are going to run on a machine that has a very little RAM or hard disk, just remember that a reel is stored as an 8-byte float. It actually takes up 8 bytes. And the integers ranges between 1 and 8 bytes, depending on its magnitude. How large is it? So sometimes you actually need to sort of try to calculate the amount of data that will actually exist in that database in the future. So it's a bit of statistics here. Just try to figure out how large it will be within a year and within 2 years and so on. And that blob, well, that blob stands for binary large object. And that's the type you use when you're storing an image, a JPEG, for instance, or a sound wave sound wave file. That's just binary data you store there, nothing more. So an example. So let's create that ages table. It should have 2 columns, person and age. So the command goes create table, ages, and then you just start to add your attributes. And you start with the first attribute. Its attribute name, its column name, its type, and then you have a comma separated list of just attributes. It's not that hard. Just go on. The hardest part, when you're getting at this, when you get to this point in your project, the hardest part is already over, because that was the modeling thing. You know by now what you're supposed to do. So that was some of the data definition language constructs. If we move over to the DML instead, there are a few constructs here as well, and one of them is select, another one is insert, update, and delete. And that's a typical scenario. Select, insert, update, and delete. Just remember those 4. That's a fairly common sequence of things. Oh, sorry, it's not a sequence, but there are 4 operations that you commonly do on your table or tables. All right? And the select, well, there you go. So if you're going to select something, then you're going to select either all of the columns or just a few of them, because there's a comma separated list of columns here. And you need to tell the server or the compiler, the interpreter, from where it should be taken. From what table should I retrieve data from? It's not always mandatory, but usually in the, let's say 99% of the cases, you are getting data from a table. And sometimes you have a where clause. So for your select, you are also selecting the columns from what table, and you are using a condition as well. And on it goes. So let's just try to get all the columns from that ages table. Well, select person, comma age from table ages. That's not that hard. And if you don't want to make that list of columns, then you go with that star symbol, because the star means all of the columns in that table ages. How many in here have used SQL before? Yeah, more than half of you. Great. Okay, so you also know that you sometimes need an operator, especially in that where clause. You need to check whether something is larger or smaller than something or equal to. There is one thing here, and that is that equal sign. Equal is equal. If you are used to, so let's say, C++, then you know that testing for equality is that double equal sign. In the SQL language, it's just one single equality sign here. And the major difference, which this is quite a common mistake that I always do, is looking for that something isn't equal. Well, that's not the same combination of symbols that you use in Java or C#. This is the one where you use the less than and greater than combination. So just remember that. And also, if you're comparing to strings, sometimes it's case sensitive, and sometimes it's not. It depends on the vendor of the database management system. Check the manuals, and you can switch it on. So let's check if we get the persons older than 5 years. What we need here is to add a where clause where we have check whether age is larger than 25, and if well, then tuple and age is added to the table. So one that is and 25 is yeah. I should say. Okay. Okay, let's try this again. Is there anyone out there who can verify my sound? Great. So we were talking about that example where we were supposed to select the persons and the ages from that table ages where the age was above 25. So it turned out that Bob was the only one because he was having the age of 34. So that select clause can do two things. It can do both the selection and the projection. And what we get here is a result. If you turn that selection and projection into those algebras we were talking about the last lecture, you will find that it is the first the selection of trying to figure out who meet the criteria of having the age above 25 from that ages relation or that ages schema. That was the selection, and then we had the projection where we selected person and age. So those two things you have there, the select clause and that relational algebra expression is the same thing. And just a warning once more, when you are using the select clause, it returns things, it returns tuples. The order of the return tuples has no meaning here. It is unordered. It can be returned in any order or in any fashion that the server finds suitable. But if you need to have that result back in a specific order, then you use that order by clause. So trying to sort that those tuples and get them in ascending order by age, then you need to tell that select clause to use age as the sorting criteria. So order by and age is your friend here. If you need it the other way around, you have to tell that order clause that by adding the keyword DESCS, that descend. So ascend is on by default, descend has to be added to the construct, right? And you can also have a list of attributes to order by, so you can add age, comma, person if you want to. So it sorts first by age and then by person. And also sometimes your query returns just too many tuples, it's just too many rows. You can then limit the number of rows to be returned, and you use that limit keyword. So in this case you are using limit 1, which means it will just return the topmost row from your query. This is sometimes a good thing when you know that your set or your bag of result will contain millions of tuples. It could be quite good to just limit it to a few of those. But that is something that you actively do. It's not done for you by any automatic means. And the pattern matching thing here, you're supposed to use pattern matching when you're checking strings. And I think that most people prefer that you use the like construct because that is pattern matching. If you would test for equality, there are a few things here. If you are using that varchar, it might actually work. But if you use that static character, it might not work as you intended, because it always adds up to the maximum size of that character as you specified when you created that table. So I think that most people, including myself, go with the like construct. Then I have no problem at all. So when dealing with pattern matching, you have a look to what is left of, right of that like keyword. There's a string there where percent, that percent symbol means any number of character of any type. If you use underscore, then you mean exactly one character and you don't care what that character is. So what you have here is a construct that says that if you have a person that has first an L somewhere, then later on in that name there's an I, and whatever comes after that is not also especially interesting, then you have a matching. So Alice is valid here, Bob is not, and Carol is not. Just back to that one. Just to remember the difference between using like and test for equality. And whenever you are getting a result that doesn't sort of meet what you thought it would be, then you are probably better off with like, because you probably used the equality sign. Oh, yeah. And sometimes you don't need a relation at all. You just can sort of return constants. And this can be useful if you are using a stored procedure, because that select statement here, it actually returns a value. It might not be that common. It will probably occur for you at some point. But you will probably have to have a look in the manual, because the only thing you remember is that, okay, I could use constants somewhere here. And there's another thing here. If you have a look at that statement which says select one as X, well, we are renaming the first column to be named X. The second one is Y, and the third one is sum. So adding a column name or a constant followed by as and a new symbol name, then that's your new symbol. And you actually do that sometimes when you have very long column names, or if they don't really match your needs, then you just change them. But that's only for that select statement here. It's only valid within that query. So as soon as you leave it, you're back to your old names. Okay. So the insert is used when you are adding rows to your table. You are using insert, and you can use insert in multiple ways. I think it's better if you have a look at it by using an example. So if you want to add a new row to your table where you're supposed to add Carol, and she is 18 years old, Well, then you first have to specify the keyword insert into, and then you tell the server the table you intend to insert the tuple or the row that comes after it. So we're instructing the server to insert Carol and 18 into the table ages. And when you are using that form of insert, where you don't specify any attribute at all here, it is supposed to be in the order in which you created that table. And that's and what I mean here is the order of the columns for that specific table. Sorry. Yeah.
What happens if you mix the types by accident? Is the DBMS able to detect that, or
yeah.
just accept the values in the wrong way?
Yeah. The question is what happens if you intermix those rows? So in this case, switching the positions of Carol and 18, well, that will turn it into a syntactic error. And at least Microsoft's SQL servers are quite cryptic sometimes when it comes to telling you what is wrong here. So the only thing you know is that there is something wrong, and then you have to go back to your statement and have a look at it to see what it is. And actually, I don't think it's a syntax error. I think the syntax is correct. It's just a semantic error. If you want to, you can use the second example here, where you are actually naming the attributes. You are naming age and person, where you're adding the values 18 and Carol. And if you look at it, it is in the other way. It's the opposite order of attributes as we were creating the columns for that ages table. And that's because we are actually telling the server that this is the order in which we are going to list the values, and that in combination with the attribute list here makes it okay. So age and 18, and the person and Carol. So that's okay. When we create that ages table, we had those columns in the opposite order. And that is why the top example works, where we're not naming those column names. And sometimes you just have a value. You don't have the values for all your columns. Then you need to specify the column name you are intending to use. And there's a bit of an error here. It says Dave. It should be a string. It looks like more like a variable here. I'll fix that for you. And this also means that the age is set to be a value that is mandatory. It's optional. It can be null. And null is a value we will sort of have a look at in a short moment. Right? If you create your table and you don't have a key at all, you can create tables without keys. It's not that good, and if you do it by design. There's a purpose behind it. But if you leave it without keys, then you can add the same row over and over and over again. That's not a problem. And that means that this is a bag. It's not a set. The problem comes later on when you ask for that Bob guy. How old are you? Well, you will get 3 rows as a result. And then you realize, okay, there are some duplicates here. So let's remove 2 of them. And that's the point where you should realize that my model isn't that good, or I have implemented that table incorrectly. It should have had a key. In any case, let's assume that there is no key here. You have those 3 rows and you just want to see one row. Then you add the distinct keyword. So using select distinct person will just return one row. And sometimes, because your table is badly designed, you have to use distinct because you get multiple results. You get multiple rows as a result. And then you get sort of annoyed because using a distinct to just remove things here, does that mean that that table is actually working? Or am I just lucky? And if you are on a project that might cost you millions, then you start to think a bit more. So that update. Well, if we have an insert, we also have an update. So that update works in at least it starts off in a similar fashion. You have your update in your table, but then you also have to tell that update what columns am I going to set and with what, and is there a condition here? Should I set the values only if the sun is shining or the age is above 20? That is what you can read from that syntax scheme. So let's assume we will set, let's assume that we have this person Carol and we want to set her age to 23. Well, first of all, we need the keyword, that update construct. So we start off with update, the table, and the expression, setting age to 23, where the person is Carol. So Bob will not be affected here. And if I warned you about the easiness of dropping things, here comes another one. If you go with that second statement, update ages set age equal to 23, well, that set all the ages to 23. Each and every row that is part of that ages table now has the age of 23. And this is a mistake that is very easy to do, because if you are stressed out, then you might fire up your user interface, and then you go for that second statement and you just update everything to 23. Yep.
Maybe this is a little bit off topic, but is there a command to like simulate the changes so you can see the changes before?
Yeah. The question is if there is a way to simulate that update, and yes, there is something called a transaction that we will be talking about in the lecture after the next one. So you start a transaction and you make your changes, and then you can have a look, and then either you commit that transaction or you roll back. You make a rollback, which turns it back to the same state it had before you started the transaction. But if you are stressed, then you forget usually to create that transaction. And if you were stressed out before your mistake, then you are totally freaked out after you have made that update. And the same goes with that delete. So let's delete all person who are named Carol. Well, delete from starts fine. Name your table that has that attribute named person, and the values should be Carol. Fine. And then the next warning. So if you omit that where clause, then you are actually emptying that table. The table itself is not gone. You need to drop it, but its content is gone. So that transaction comes in really, really handy sometimes. And there is, if you're lucky, there's a fix for this, because every command that you issue here is logged. So if you're lucky, you can reverse it, then you need to call the database administrator, and they are usually quite grumpy. So don't forget that where clause here. So then you know by now that the difference between delete from and dropping. Delete from removes its content, and drop removes the table itself. Oh, and if you think that you can issue drop before the table is empty, then you're wrong, sort of. You need to delete the content first before you drop it. So fail safe to a certain point. And I have to say, when you issue a drop on a table and it says that, okay, it's not empty, and then, okay, so let's empty it. So you issue a delete. Well, then you should stop for a second. Why isn't it empty before you drop it? Just a question to ask yourself here. Okay. I told you before that we had that insert. We inserted Dave into that ages table, and we didn't supply an age. And I mentioned that word null. Well, what happens here is that if you don't supply a value, it will set that column or that attribute to null. And if you are a C or a C++ programmer or a C# programmer, you know what it is. There are a lot of discussions whether null is good or not. I think until the end of time, that discussion will be there. But if you have a good strategy for using those null values, you can actually use it. So if you set it to null, then it means that there is no value. So you can check for null values if you want to. There is also when you're creating a table, you can always tell that create command to accept null values for a column, and that is something that you do by design. So if you are supposed to supply a value, to always supply a value for a column, then when you create that table, then you shouldn't allow null values for that specific column. Some programmers do not like null values, because when they retrieve values using their language, they get sometimes null values back, and when you use a null value inside, let's say, C#, then you get an exception thrown. So adding two values together, and there's a null value somewhere in there, then you get an exception because you cannot add 1 plus a null value. It makes no sense. So what they do instead is that they don't accept null values, and then they have to add a default value, meaning there is no value here. Their code will pass, but it will behave badly. So stick with those null values. It means that there is nothing there. As a programmer, okay, you have a bit more to do, but your program will behave as it should. So that null construct, that null thing, is making things worse because SQL uses something called three-valued logic. Because if you have some logic here and there's a null involved, well, is it true or false? Does it mean anything? So this is what they do. If you make that null meaning unknown, you don't know, and then you say that if you have true, let's assume that is 1 and false is 0. Then you can do the following. You can define and as the minimum of those two, or as the maximum of those two. So if you have a look at the row that starts with true and false, that becomes the minimum of 1 and 0, and the minimum of 1 and 0 is 0, which means that that turns into false. And let's further assume that we define unknown as the value of 0.5. And we set that false or unknown becomes the maximum of that 0 and that 0.5, which turns it into 0.5, which is unknown. And suddenly then not works as we want it to be, because we set it as, if we assume not x, then it means 1 minus x. So not unknown turns into 1 minus a half is a half, and a half meant unknown. So not unknown is unknown. That's the three-valued logic here. So that null value messes things up a bit, but there's a solution to it. And there you have it. P or not P. I think that's a version to be or not to be. So turning that P or not P into our max, and that minus, where we set not to be 1 minus whatever value you had, well, then that turns into unknown. So that should always be, I mean, the first one, P or not P, is always true, but not when you are having unknowns. Then it turns into unknown, which is okay. You just have to go back to what we defined and then use it and make sure that, okay, there is some sense going on here. And this is why, if you are using your relational algebra and use it on a tuple containing null values, then it should behave the way it does here. And this is just a discussion whether Dave should be a part of the example or not, because if you have a look at that statement, the select statement, it says h is larger than 10 and h is less or equal to 10. Well, should Dave be a part here? No. because null is an unknown value. You cannot say anything about it. So when you're doing those joins later on, there is a reason for why there isn't any null value supplied, or where it shouldn't be there at least. And this is also, let's assume, because this is a fair question, should we check something to see whether it is null or not? And if it is null, well, should we do something? So I think most of us would think like, okay, let's assume that we use that equality symbol once more, just the way we have here, where we have select person from ages where age equals null. Well, null is unknown. You cannot use that on equality testing. So what they want you to use is that is construct. Then it makes sense. The operator, the equality operator, doesn't work on unknowns. So let's use is instead. And that's what you have on the last row, where it says select person from ages where age is null. Now it makes sense. Okay? And this is a shorter discussion whether you should use it or not. I think I've made my point quite clear. Use it. It's a good thing if you have it as a part of your strategy. If you don't know what you're doing and you're still using null, well, just stop it, take a step back and think things over once more, and then go for it. You need a strategy for it. If you have a look at it here, we said that we can use, if we don't want to use null values, you could always supply a standard value, meaning that something is missing. And that is usually the minimum or the maximum value for that type. Let's assume we have an integer, which is a very large number or a very large negative number. But you can be certain at some point, that large value, that maximum value, will be in play with your algorithm that you're actually using. And some people assign -1. If I have -1, then I know that that value, that attribute or that column isn't filled in, it is missing. Well, then your programming logic changes. So suddenly you're supposed to use negative numbers as well. And you have to go through the entire table to make sure that there isn't any -1 there. So you set them to -500 instead. And then you're back. Don't do that. So let's move over to functions. And there's a lot more than this. This is just a couple of them. If you would to turn your person names into the uppercase, then you can apply the upper function. And what is happening here is that it's just the result of that select query that makes the names in uppercase. That name is still stored in whatever state it is. It's just from the result of the query. And the same goes with that average function. It's just a result from the query. It won't affect anything else. So using the average here means that selecting average, and then you want to use a column. On what column are you supposed to create your average value on? Well, then you need a column that has an integer value in it, or a float, or a real. And count is a function that you sometimes use. You want to check how many that meet a certain condition, or the maximum or the minimum or something. But I think that count is a good function to remember here. Okay. And the heading here says adding another table, and it means adding another table in a query, in a select query. Sorry. Let's skip that one for a minute here, and let's go with that one. Here we are. So if you have your two tables, ages, which was the only one, and gender, which is a newer one, which just contains the name and a gender, what if you want to combine these two tables, the tables age and gender? We talked about joins yesterday when we had that last lecture. And what we do here is that we try to figure out which ones are of the gender female. And what you see here will not work. And the reason for that is that what is returned here, firstly, is the Cartesian product of ages and gender. And after that, then you apply that where criteria on it. So that won't work. We did actually talk about this yesterday. So using the Cartesian product on those two tables, ages and gender, produces quite a lot of rows. And then you start to select by checking for where gender is equal to female. And then you will turn up with too many results here. There are too many rows. So something is wrong here. So somehow we need to connect those two tables in the correct order, in the correct fashion here. So what we actually mean is that the same person that you find in the ages table should be connected to the same person in the gender table. The same person in the ages table should be connected to the same person in the gender table. And then you apply that, and gender should be a female. That means that if you go back to that, you see that on the top row you have Alice, 25, Alice, and female. Well, person in the first column on the first row is the same as the first row in the third column. Let's see if I can switch over to the camera. That's correct, but those two are not the same, so they shouldn't be a part of that answer. And that is what you actually get when you add that testing for the person attributes from those two tables. They should be equal. So that row will not match, just because of the names are not the same. That will not be true either, not that one. And Bob and Alice is not the same thing. Bob and Bob, all right. Those two are the same. I used a square, so let's assume that I'm using a square here, which meant that they are okay. So Bob and Bob, all right, those two are correct. They are matching, but he's not a female. So he's not part of the query result. And Bob and Carol doesn't match, and so on. So it means that you will only get Alice and Carol as a result set. So if you don't do those joins correctly, you will end up with the Cartesian product. You need to reduce that set.
Question?
Yeah.
Could you use like instead? The keyword like.
Yeah, that would be equally fine. I would probably have gone for the like here. So just be aware of that Cartesian product. Just a few words on those aggregates. Sometimes you need to combine your values and group them together in meeting some of your criteria here. So let's assume that we want to know the average of each gender. So that means that you are sorting those gender-wise, but you cannot use order by in that sense. So what you need here is another keyword which is called group by. So there's a grouping going on here, and you are grouping by the gender because that's the group you want to know the average for. So it then also applies the attributes gender in the select clause and the average function. But that average function now works per group. It works per group. Remove that group by and remove that gender attribute from the select list, then you will get the average overall. Grouping makes it per group, all right? And putting a criteria on a grouping requires you to use another keyword that works in conjunction with the group by, and that's having. So we are only going to display those groups that is having an age over 30. So you cannot put that average in the where clause. It won't work. All right? So that will return the males. So we go back to the previous slide, because the females has an average age of 24, and we are going for the ones above 30, which are the males. So just remember that grouping and you have a condition, well, then you need having. But you can always go with the where clause if you're having some other conditions, if you want to. That's fine, but that's that's the selection, not the aggregate. So that's the reason for that grouping. You are grouping by some expression, which could be a comma-separated list, and then you either go for the having because you have to check something, or you skip it and move on. So let's move over to those joins. So there are some joins that you can use in the query language if you want to. There are some, and I should also point out that not all vendors support these things in this fashion. They might have some syntactic changes here, so just have a look in the manual, right? And prior to the SQL 92 standards, I don't think that this actually existed. So you have those joints, you have your natural joints, and you have your left and right left joints and outer joints and inner joints and cross joints. And all of them move back to what I was talking about yesterday when I was talking about those equi joints and theta joints and all those. And they can be quite good to have if you need them. So those joints combines those tables based on their relations. So if they are going for the equality, then you have your equi joints I was talking about yesterday. And if there's a condition to that join, then you're in your theta join. And I should also point out that sometimes using actual joins are preferred because you can affect the way that join is made. Because if you're not using the join, if you're just using the Cartesian product, then you cannot affect the way it combines the tables involved in that select query. That can be done using an actual join. So you can sort of hand optimize things if you know what you're having in those involving tables. But let's go with this example where we had the same select query. That's the first top example, where we were supposed to get only the females, and that was the Cartesian product. But if we remove that and go for the theta join with equality, then we need to use another keyword. This is another construct. So we're going to use ages and genders as before, but we're going to use the keyword join in between. So we're going to combine and join ages and genders. And we're going to use the attributes or the columns persons. The persons from the ages table and the person column from the genders table. Those two are the columns being a part of that join. We are naming them. So you could take just about any column from any of those two tables, just as long as they mean the same thing here. So the column names might be different, but the meaning should be the same. Otherwise, you're not doing the thing right here. And since the the column names from those two tables are the same, they were person, you could instead go for the last example, where you are saying from ages join genders using person, which means use the person column from those two tables. All right? This is where things, if you're a bit tired, you probably need to take a break here. Because if you're doing it, sometimes if you do it the wrong way, especially when you're having outer joins, you get a result that is not correct. And that natural join is something that we talked about yesterday. So if you have that natural join, you just can tell them to check all the column names between those two ages and gender tables. If the column names are the same thing from both tables, and whatever is in those tuples are the same thing, then that criteria is met. They are joined. And I'm not actually sure that you have natural join in Microsoft SQL servers. I might be wrong here. Yeah, and just note here once more, there's a dangerous thing here. If you start to add columns or change the name of the columns, then that selection might fail. But you shouldn't change the name of a column when it's live. I advise you not to do so, but sometimes you need to add a column for some reason. Just make sure that you don't add that column so it has a name that is equal to a column in an existing table, in another table, because if that is so, then you are actually affecting that natural join you're having here. That's why you need to check your system and have a good documentation for it, or at least sit down and have a few moments by yourself. Right, so what we have had before is an inner join. There is also an outer join, because if you're having inner joins and you're matching against null values, it won't be a part of that. Matching against a null value is not valid. It's nothing. It's unknown. So it will not be added to the result set or the bag of that selection query. But if you want it to be a part of your result, then you need to use outer joins. And then you specify sometimes whether it's a left one or a right one, and that means that you are supposed to either add the null values from the left table or the right table. And if you're having a bad day here, you get some strange results. So what they say here is that they are adding someone called Eve, but they don't supply an H for it. So if you are joining using a normal, that won't be added to it. But if you are using an outer join, the result will be with that Eve added to it. So that's the normal one. We are selecting every column that we have from ages, and we join them with the genders, and that's the inner, which is the default one, and we're going to use the person. So we get 4 rows in our result set, which is fine. But if we get the left outer join instead, then we are using the same criteria for searching, but we are also adding Eve from the ages table. She has an age, but she has no gender. And that, what you have there, is a null value. There's a null value in the gender cell for Eve. And that's the difference between inner and outer here, for our purposes. So this means that if we are checking for persons that has no gender, well, then we need to use that left outer join. And there might be some tricky things going on here, and I should also point out that you can have as many tables as you want in a join. You just keep on adding them, join after join after join. Just do it. If you are, I think that most people, including me, are preferring using over that natural construct. I think I use using everywhere I can, That feels good with me. And that's my preference. You might have another preference. The only thing I can say is that if you have started it one way, stick to it. Don't change your strategy for creating things here unless you have to. And this is the same discussion I think I've had before for naming things. If you like camel casing or Pascal casing, the worst thing you can do is that every second variable name you have is camel casing, and every second the other way is Pascal casing. It looks just awful. Stick to one strategy. And I also mentioned that we should prefer join over that cross product because we can affect the performance using joins. When we're using the cross product, we can't. It's the server that is the decider here in that case. Yeah. There are a few other more constructs here, like the union, the intersect, and so on. Sometimes you need it. I cannot recollect if I ever have used intersect. Perhaps. So it's just this is just a common set operation in itself. You are combining the sets of ages and genders, and those that are intersected, that's your result here. That's what you're going for. Oh, and if you want to, you can join your self table. That could be a good thing to know. Right, any questions? I think I'm done here. No, I'm not, but I'm done. This is more about the subqueries. Subqueries can be quite handy at some points, but you can easily use a join if you want to. Questions? Right. See you tomorrow then.